In this section, we're going to talk about routing basics. Let's start with the routing basics. And what is a router? A router is a networking device that forwards data packets between different networks. Main job of the router is performing IP routing based on routing table, and routing table can be established by manually configured static routes or dynamic routing protocols. This is the router. This guy has a routing table in it, and the main function of this guy is making IP routing based on the routing table. Let's go ahead with the router components. In a router, we have components such as IOS, which is the operating system of the device, and some hardware such as CPU and memory and storage such as flash, RAM, ROM, and the NVRAM. As we talked before, the main purpose of router is connecting different networks. In here you can see two different routers, which are router A and router B, and these guys are used for providing communication between two remote networks, and they are 1-0 network and the 3-0 network for this example. Let's go ahead with the basic router configuration. When we are configuring a router, firstly, we can configure a host name. Secondly, we should secure our enable mode, console port, and the VTY ports to provide secure access. To configure a host name on a router, our command is hostname, and we are typing hostname and the host name that we want to define, and as soon as we hit the enter key, as you can see that host name is turning to the my router in here. Then we are defining an enable secret password, as you can see, enable secret, and we are defining a password in here. After, we are securing access to our console port by typing line console 0, and in the config line mode, we are defining a password again. After, we are defining a password also for line VTY access ports, which are the ports used for the remote access. Then we are defining a remote access method, which is SSH, the secure one, as you know. Then we are typing the password and our password for the VTY access, as you can see in here. To configure an IPv4 address on a router interface, we are getting into the interface mode and typing IP address, IP we want to use, and subnet mask command. Router interfaces are not activated first, and they must be activated by the no-shot command, as you can see. In here, we are getting into the interface mode again, as you can see, to assign an IPv4 address to our router interface. Then the command is IP address, and the IP address we want to use, and the subnet mask we want to use. Let's go ahead with the IP version 6 interface configuration. If you want to activate IP version 6 on a router, firstly, we should enable it by typing IPv6 unicast routing command. To configure an IP version 6 address on a router interface, we are getting into the interface mode, as you can see again, and typing the IPv6 address and the IPv6 IP address and the prefix length that we want to use. Then again, the plus no shot. Let's go ahead with the router loopback interface config. A loopback interface, guys, is a logical virtual interface in a Cisco router. A loopback interface is not a physical interface like fast Ethernet interface or gigabit Ethernet interface. A loopback interface has many uses, guys. For example, loopback interface's IP address determines a router's, for example, OSPF router ID, and also it allows BGP neighborship between two routers and something like that, etc. A loopback interface is always up, guys, don't forget it, so you don't need to use no-shot command for a loopback interface. To define a loopback interface IP address, we are getting into the interface mode again by typing interface loopback and the loopback number we want to configure. Then the configuration is same with the other guys. So let's go ahead how we can filter our show commands. To filter our show commands, we have 4 options, and they are include, exclude, begin, and the section, guys. To filter show command output so that it only displays lines that contain a particular regular expression, we can use the show pipe include command in exec mode. In here, as you can see, we are typing show process CPU pipe includes IP input, and we are seeing the line which includes the IP input keyword, right? Exclude filters show command output so that it excludes lines that contain a particular regular expression. So in here we are typing the show IP interface brief. This time we are excluding the unassigned lines. So in here we don't see any keyword like unassigned, as you can see. Then to begin the output of any show command from a specified string, we can use show, for example, show and the command pipe begin. In here we are seeing the lines beginning with the line VTY, as you can see, line VTY 04 and 515. And lastly, to filter the output of a show command to match a given expression as well as any lines associated with that expression, we can use the show, the command, and this section in here. For example, show run pipe section router EIGRP shows us the specific EIGRP configurations made on our router. For example, we can use show run pipe section OSPF, show run pipe section BGP, or we can use show run pipe section crypto, and we can just see the specific configurations for that technologies. Let's go ahead with the routing decisions. Packets journey on a routed network. In here, guys, we have 2 clients, and they are James and the Johnny. If James wants to send a packet to John, first packet will be sent to default gateway, guys. Why? Because in here we are using 1.0, and in here we are using a 3.0 as a network ID. So here and here has different network IDs. So because of this, James will forward the packet to the default gateway, which is here. Then router A will take the packet and check the destination IP address. To forward the packet to router B, we should tell router A about the 3.0 network. For this purpose, we can use dynamic routing protocol or static routing, saying that, hey router A, if you have a packet with a destination of 3.0 network, send it to 2.2 IP address. Then packet reached the router B. Router B is directly connected to this local area network and will forward the packet to the Johnny in here, as you can see. Then packet reached to Johnny, and Johnny also can send a reply back to John. Okay, so we should do the same thing on router B, saying that, hey router B, if you want to reach the 1.0 network, send your packets to 2.1 IP address. Let's go ahead with the path selection. If you want to establish a routing between two sites, we have two options, and they are static and the dynamic routing. If we're using a dynamic routing protocol, and if the administrative distance and prefix length values are the same for different protocols, always protocol with the lowest metric is preferred. If metrics are equal to, routers make load balancing between different paths. Metrics are the cost values used by routers to determine the best path to a destination network. Several factors help dynamic routing protocol decide which is the preferred or shortest path to a particular destination. Metric is calculated differently for each dynamic routing protocol, and the metric is, for example, if you are using a RIP protocol, your metric will be the hop count. If you are using OSPF, your metric will be cost value, which is dependent with the bandwidth. Administrative distance is a value that routers use in order to select the best path when there are two or more different routes to the same destination from two different protocols. Administrative distance counts the reliability of a routing protocol and is a numeric value which can range from 0 to 255. A smaller administrative distance is more trusted by a router. Therefore, the best administrative distance being 0 and the worst is 255. For example, under the same conditions, always, for example, internal IGP routes are preferred over the OSPF because this guy has lower administrative distance. Let's go ahead with the router operations, and we are starting with the static routing. Static routing is a form of routing that occurs when a router uses a manually configured routing entry rather than information from a dynamic routing traffic. Unlike dynamic routing, static routes are fixed and do not change if the network is changed or reconfigured. This kind of routing, static routing, guys, is more suitable for very small networks only. So let's take a look to the IPv4 static routing example in here. In router A, we are making an example static route configuration. To configure a static route for the router A, for this network in here, as I told you on the previous slide, I told you that if router A gets a packet with a destination of 3.0 network, we should teach this guy how to reach to this particular destination. So the configuration in here is IP routes, the network that we want to reach with its subnet mask, and the next hop. This command is saying router A that, hey router A, if you get a packet destined to 3.0 with this subnet mask, send the packet to 2.2, which is this interface of the router B. So let's take a look to the IP version 6 static routing example. That's the same logic, but what we are doing first is enabling the IP version 6 routing by typing IP version 6 unicast routing command. Then we have a bunch of routes in here, and we are defining the IP version 6 route commands and the destination networks and the next hops, which are here this time. Let's go ahead with the IPv4 default static routing example. Static routing can be used to define an exit point from a router when no other routes are available or necessary. This is called a default route, which means send everything a single exit point, which is 2.2 for this example. For example, what we are saying to router A in here, IP route, hey router A, send every packet that you reach. This means every packet that reaches the router A, send everything to 2.2. So whatever the packet, every packet comes for the router A will be forwarded to 2.2 IP address. And it's the same thing for the IP version 6 default static routing again, but the command is IP version 6 unicast routing that we need to implement first, as you know. Then we are typing the IP version 6 route with a double column /0, which is the identical of 0000 0000 in IP4, which means everything, then will be forwarded to this interface this time. Let's go ahead with the floating static routes. Floating static routes are the routes used for creating a backup path. In this method, you define a higher administrative distance for backup path, and so that route is not available in normal conditions. The floating static route will be only active when the primary route fails. For example, in here we have a router which is router 1, and we have two static routes configured, two static default routes configured for this router. And in the first route, we are forwarding our packets to 10.23.0.2, which is here. So the packets coming to this guy are being forwarded to here always. But we have another route in here, as you can see, which is forwarding the packet to 10.22.0.2, which is here. So if this route fails, this route will get into play and our packets will be forwarded to here. Let's go ahead with the route summarization. Route summarization, also called route aggregation, is a method of minimizing the number of routing tables in an IP network. It works by consolidating the selected multiple routes into a single route advertisement. It contrasts to flat routing, in which every routing table contains a unique entry for each one. In here, as you can see, router 1 will represent 4 separate networks using a single network. In here, we have 10.22.00/16, 10.23.00/16 again, 10.20.00/16, and 10.21.00/16. And we are using a summary route which is 10.20.00/14, and we are representing all 4 networks using a single network. Let's go ahead with the CIDR, classless interdomain routing. CIDR is a way to allow more flexible allocation of IP addresses than was possible with the original system of IP address classes. As a result, the number of available internet addresses was greatly increased, which, along with widespread use of network address translation (NAT), has significantly extended the useful life of the IPv4. And CIDR uses the VLSM to summarize routing tables in routers to more general addresses. Let's go ahead with the dynamic routing. Static routing, guys, allows routing tables in specific routers to be set up by the network administrator. Dynamic routing uses routing protocols that dynamically discovers the network destinations and how to get them. Dynamic routing allows routing tables in routers to change if a router on the route goes down or if a network is added. In dynamic routing, routing protocols running in routers continuously exchange network status updates between each other as broadcast or the multicast. With the help of routing updates message sent by the routing protocols, routers can continuously update the routing table whenever a network topology change happens. Examples of routing protocols are RIP, EIGRP, and OSPF maybe. So, the dynamic routing protocols that we can use in an IP version 4 environment are, as I told you, RIP, EIGRP, OSPF plus ISIS and the BGP. The dynamic routing protocols that we can use in an IP version 6 environment are RIP-NG, EIGRP for IPv6, OSPF version 3, and the multi-protocol BGP 4.